In the previous film, I showed the function blocks for timers. Now I will use one of them, the T-on, in an example in Codesys. This is the example. I have the same motor as in my latch examples. I have a motor that is started by either one or two start buttons, start 1 and start 2, and it's stopped by the stop button. But now I will add a timer that makes the motor run for a maximum of 5 minutes before it automatically stops. I have started Codesys and I have my previous programs with the latches here. I have the ladder latch, which starts the motor by pressing start 1 or start 2, and the motor is stopped by pressing the stop button. Remember that the stop button is normally closed, which means that it's true until the button is pressed. And we have the latch where the motor remains started. And I have the program with set and reset coils. And I have the function block diagram program with the RS latch. I will start in this program. We already have the function for starting and stopping the motor. Now we want to add the function of stopping the motor after it has been running for 5 minutes. For that I need a timer. The motor should be stopped either by the timer or by the stop button. So we need to start with the logic block OR. We have them here, the Boolean operators and an OR block. Drag it and drop it. Now I see that this negation is in the wrong place. It should be here. Then I remove it from here by right-clicking, choose negation, then it's gone, and do the same thing over here. Right-click, negation. Now the motor will be stopped when the stop signal becomes false or something else. Here I want to have my timer. I will use the timer T-on, timer on delay. I can find that timer here. You can see that the TP timer is not here, but it still exists. This is just some of the blocks that we have. If I want to have a block that is not here, or one that is here, but I don't find it, I can use an empty box and drag it and drop it. Now it's anything, but I can write here on those question marks within the box what I want the box to be. T-on. And now we see that the T-on block, just as the RS block, needs a name. The name can be rather long if you wanted to. Motor stop timer. That is not the name that I have declared before, and I need to do it. Codesys says that this is probably the name for a T-on block. Yes, it is. Okay. Now we have the variables here. The ET does not need to be connected. I can remove the question marks here, or I can remove the output entirely by clicking on the pin and delete. If I have removed the pin that I actually wanted to have, I can right click on the block and use update parameters. Then it's back. I remove the question marks. I don't want to have that one. Now, this timer should measure the time from when motor was started, which means that I use motor over here. And then the timer should run for 5 minutes, T hashtag 5M. Now, when the motor starts, this timer will start as well. It will run for 5 minutes, and then the output will become true, which will stop the motor. If I want to simulate this, 5 minutes is a rather long time. I will use 5 seconds. Now I can test it. Before I test it, I have to make sure that I'm running the correct program. I will run this program, drag it to main task, drop it. And I don't want to run the ladder latch program because then they will both write to motor. I just delete that one. Now I can log in and start my program. And now I can test it. I know that for this motor to run, I need to have stop true. I'll start by that. Now I can actually start the motor. I do that by pressing start 1, and then I will release it immediately again. Now we can see this clock. This is running for 5 seconds, and now the motor is false. During the time the motor is running and this clock is running, I can still stop the motor. I can start it again now and stop it with the stop button. And it immediately became false and the clock stopped, which means that this clock will run as long as the input signal is true up to 5 seconds or 5 minutes that we want it to have. I will log out and try the same thing in the ladder programs. I will start with the program where we have the S and R coils. Here I start the motor by pressing start 1 or start 2, and I stop it when stop is false. Now I want to add another opportunity to stop the motor. In this program we saw that we wanted to have an OR function, and we can make that in this ladder program as a parallel branch. I will make a parallel branch here below. And here I can insert my function block, my T on. I use an empty box or the box from the function blocks, drag the box and drop it where I want it to be in my parallel branch after my contact, and I write the name on the block. As before, this time you should have a name. I am using the same name as in the other program. That is okay because it's a local variable, and I have to declare it in this program as well. As we can see, we can use a function block within the ladder diagram. In order to do that, the function block needs to send out at least one signal that is a Boolean, because the ladder program uses Booleans, but we can still have this signal that is a time and this signal that is a time, but they are not connected to the ladder rung here. I remove the question marks for ET. I set the time, T hashtag. I will use 10 seconds this time, and the variable motor that will start the timer. I've done the same thing but in ladder. And now we'll run this program. I will remove this one from main task and drag the correct program to main task and log in. And I start my program. I can see that the motor is stopped to begin with because stop is false. I will make stop true, and now I can start my motor. Just as before, I will start the motor and I will immediately release the start button again. And if we check ET on this timer, we will see that the motor will run for 10 seconds before it stops. Now we can see the ET running up to 10 seconds, and then the motor stopped. The input signal to this motor stop timer became false, and this is reset again. Now I can restart my motor. And I can stop it with stop before the 10 seconds. This seems to work. I can log out, and I will do the same in the other ladder program. I will copy this timer and then I can paste it in here. But I cannot paste it in this rung. I will need another rung for that. I can right click on my network and choose Insert Network below. And here I can insert my timer. It has to be declared. Now as I just copied and pasted it, I didn't get that auto declare, so I need to declare it myself. Like this. Now I want to have a variable that can stop the motor. That variable will be the output from here, and I will use it over here. I can put the new variable, stop variable, here or here. I will add it here as a negated contact. It will stop the motor when it becomes true. I give the new variable a name, stop time. It will stop the motor after the preset time. And that same signal will be my output here. Now, motor will start the timer. When the timer is done, this variable stop time will become true and it will stop the motor. I just have to make sure that I run the correct program. Log in and start. Stop should be true. And I can start my motor. And the stop timer is running. It became true very shortly, but enough to stop the motor. Now I see that the timer on block can be used in either function block diagrams or in ladder, and they work in the same